general studies have shown, I mean in particular, before I say that actually this was the work I did when I was at Cisco Systems, I mean now I'm at Microsoft. There were several studies that indicated that a lot of customer found defects actually could be attributed to unit testing. In other words, they could have been prevented had that been a proper thorough elaborate unit testing. And there are also people who question return on investment. I think there is certain valid reasons for that. And then, so if you look at some of the popular UT frameworks, actually there's no shortage of them, plenty of them, and they are very heavily on bookkeeping. So you have frameworks like Cunit or whatever, all that. You have a lot of effort that goes into organizing your tests, structuring your tests, and so on, and then not much of help in terms of bug finding. Okay, that's what I'm going to tell you. They are important, but really we need help. Yeah. Okay, thanks. We need help in finding bugs in the code. So if you look at the proportion of the code that's actually used for finding bugs versus bookkeeping or organizing, the testing code is actually very small. And we evaluated several UT solutions, and then we developed our own. You'll see why it's a basis. And then there's also the code that actually gone through a static analysis. SS stands for static analysis, and in Cisco, static analysis is a very big thing. Investors invested a lot of effort and a lot of money resources on actually deploying static analysis across the country. So it is a requirement. All the code goes through fairly thorough. In fact, what's used there is one of industry-leading solutions for static analysis. And as it detects a lot of instances or ignored, and these are all the common issues that you detect in static analysis. And then the environment is a lot of you are familiar. These are the routers and switches that use Cisco's proprietary operating system IOS, and this is the environment in which this framework was used, and that's the target. And primary interface is CLI. If you go to bookstores, you'll see that there are a lot of books written about how do you configure routers and how do you interact with them. It's all primarily based on command line interface. And then it's a huge code base, and the main programming language is C. Almost all of it is written in C. There's a tiny fraction in C++. It's a proprietary OS that's called iOS, Internet Operating System, and it's a huge customer base. I mean, it's claimed that 85% of network traffic goes through. And its framework is used by developers and testers. Testers use it for white box testing. Now, one of the key features of them is that this framework actually directly supports bot-based testing. So users actually, that is the only way. In other words, every test is a model. In the most of the tests that we write, most of it that get written, you can consider the degenerate case of a model where there's just there's only one node in OITS, but that's how it is. So every unit test is modeled as a directed graph. And there is a built-in support for fault injection, and there is automatic generation of robustness tests for APIs. So we have several APIs, and then I see that actually in my current job also that people are actually writing tests to test robustness of APIs. Whereas there are actually techniques whereby you can do basic robustness testing automatically. This is again a work that those of you familiar with in Carnegie Mellon University, there's a project called Ballista. They wanted to harden some of the standard Linux APIs. Cisco actually collaborated with them, and then we sort of redeveloped the tool internally so that it could be deployed across the production code base. And there is built-in capability for performance and scalability testing, and then of course all these are parameterized tests. And then other features, code coverage is an integral part of Qt framework. And this is also the feature. Interestingly, those of you who use GCC and the code coverage feature on GCC, there's a GCOF feature, was actually it was a Cisco sponsored project. In fact, it was a contribution. I mean, the work was done by a third party group, but actually it was funded by Cisco. So the code coverage is an integral part of this testing. And in this framework, that is an integral part. In other words, it's very easy, and in fact, it's expected that people actually do the code coverage, not so much with the view to meet certain number thresholds, but understand what's not covered. That's the idea, is that you look at the code coverage and what's not covered, see how we can fill the gaps. And basic robustness testing is extremely easy. What the framework would do is you just list your, in fact you can just point it to your header file, or you can list the specific APIs, and then the tool would actually look at that, analyze code, and generate tests for that. The idea is that it's not so much a test for semantics or any, semantical correctness of what we're executing, but robustness. So making sure that the code that we are testing can withstand all these inputs. So we send the valid inputs, these are legitimate, that conform to the types, it should be able to handle it gracefully. In other words, you look for crashes and hangs and other bad effects of misbehavior. And the test code is automatically generated. So engineer's product is a key consideration. You look at there's a company where part engineer revenue is pretty high, and then we think that their product is paramount. They shouldn't have to do anything more than that's necessary to accomplish the job. And this is more specific to the code base. As I said, the code base is huge, the build times are huge. So one of the barriers to people using any kind of unit testing is the incremental build time is very large. Even if you make a one-line change, you have to do this big build and then run all that. So as part of the framework, there's actually a very nice mechanism for rapid incremental builds. So you can actually dynamically change it and load it onto the target on a router or switch and execute your code right there. So instead of taking several minutes, sometimes hours, now it's down to less than a minute. So you can rapidly go through this test development, your testing, and then you can enhance your test pre-run. And this is also integrated with the test automation system. So unit test can be part of an overnight regression test. And this is the workflow, is that you design, identify independent test, create a test model, and then create a test. There is a template. I'll show you a sample specification, and then you generate, the tool will actually generate the necessary C files. These are, it looks at your specification and generates C files. They are linked with the target and load the image and execute the test. And then analyze the test results and examine the coverage. As I said before, the idea is that you look at what's not covered and then try to enhance the coverage. Or else, if you can't enhance, provide a feedback to test engineers saying that these are the features that are very difficult for me to do here, so or it should be part of a system test or other forms of testing. This is a sample specification. So actually the test has several sections. You can see, we have a prologue that includes the declarations, and then you declare the environment, like what are other language models that need to be linked. And there's also a lot of code sharing here. So users are encouraged to actually create the test library so that anybody can use that. So you write the code, you commit it to the repository. And one thing I didn't mention is the tests also go into the same repository as the source code. In other words, it resides with the code. And the expectation is that when you change your code, and if there is an impact on the test, the code is also revised. Test code is also revised along with it. And then you decide what are the components or files that constitute the unit and test, because these are needed only just those are instrumented for code coverage, and they're also used for fault injection. Okay. And this is a set of functions that need to be intercepted and faults injected. And then these are the APIs. These are the so the robustness tests are generated for these APIs. And then there are parameters. And then the interesting part comes here, is that this is how you specify the test itself. As I said, you structure your test as a directed graph, and then engineers actually encode that here. So you associate code with each node and edge. As I said before, test is structured as a directed graph, and then code is associated with nodes and edges. And then what the framework does is it generates there are several parameters to this, several options. It generates a tour of the graph and ensures that all nodes are covered. There are also other options, like you can cover every adjacent pair of edges, or you want random, or there are multiple possibilities there. And as nodes and edges are traversed, corresponding code is executed, and then, as I mentioned, various traversal options are available. A simple file system model is that you have you start with that, and then following that you're going to read write, and following that you do close, and within that you can go back, you can do more reads, you can do more writes, and you can do go between that and all that. This is just an example, but typically for any component, you actually have this kind of structure. So you have a set of APIs that depend on other APIs and so on, and then you accomplish a task by the sequence of APIs, and that's what it does. You specify that, and then the underlying mechanism actually generates a different sequences. And what's fault injection? It's capable of interception of function calls and return error conditions. So you typically have like a memory management or whatever the services you're using. I have a graphic I'll show you, so you can intercept and then actually force error conditions. Because one of the problems we saw actually over the years is that the code that's often not touched is often error handling code. In a regular test environment, in our local testing, we often have all the resources that we need, and this is all that's a code that often gets executed for the first time at a customer installation. I have looked at many bugs that actually happen. I mean, this is a standard C code, so you run it first time, chances are it won't. I mean, and that's what happens. So the error handling code gets hit somewhere in the field, and then there you see a crash there, there's a hang there. So we are now actually ensuring that we actually hit a different error handling code in the unit test. You can also simulate exceptions and delays, and there are different policies for fault injection. And as I pointed out when I was looking at the specification, so you specify the components and functions of interest, and then actually the framework does the rest of the work. So it does the interception mechanism. It in a way it builds a shell around a unit test, and so it generates. As you execute, you can say that simulate faults. It will actually do the execute test in conjunction with fault injection. So this is the mechanism. It's a normal flow, and then now this is a wrapper that generates. Now this call becomes something else. The transformation is done at compile time, and so now the wrapper automatically generated wrapper gets control, and it really decides to return out selectively. So the similar technique used for different APIs. So the calls are intercepted, and then faults are returned. And then how are robustness tests generated? So tests are to exercise APIs that are auto-generated and executed. Various values are used based on the types of the parameters. So users need not bother about creating simple API calls. This is a point I want to stress because I'm seeing that in the current job, and also that good deal of test effort is actually going in very simple API calls. I mean, we create all this whatever the framework we use, we actually call that, we choose different values, and then that actually pretty time consuming. If that aspect is taken care of here, I mean, still I'm not saying there is a lot of scope for creative testing, but this is the kind of testing that actually can be automated. So in fact, this is a key point, is that they don't bother about thing, but they should focus on various API sequences with MBT. So users are actually required to look at their APIs, think of different sequences, create this model, and then run their unit tests. So how do we make a unit test? This captures some of the concepts we talked about. This is a unit test. So these are the different APIs. Actually, these calls are generated. And then fault injection is done here. So the faults are intercepted, and then error condition returned. So we make unit test robust by invoking different APIs and intercepting and generating faults in a systematic manner. So what I'm going to do next is provide a comparison. Because I picked up two features which were actually tested using a standard called a Unit. I mean, there are actually n number of such frameworks, and we picked it, and actually the development teams developed a test for that. So what I did was just took the same test, didn't add any test code, and then encoded in the new framework, and I'm going to show you the results of what we see. So these were the written, and then this test was modified to work on the new test. Test code itself was not modified. In fact, I wouldn't know the implementation of those components. For the first feature, so we had the old framework, there were 8 that were found, and then when we invoke the new one, and actually see that they have API robustness bugs there were these of fault injection, and then sequencing bugs. And then, so we actually have obviously we found a lot more faults using the new framework, and then it's not that we used actually any more effort on it. It's actually the framework, the capabilities that are provided there were actually pretty valuable in doing it, and these are also, we can say, pretty much come for free if your framework has all these capabilities. And then there's a change in the coverage, and then actually the code, the specification code has dropped substantially because we threw out completely. If you look at it, Cunit or any of this XUnit, all of this thing, there's a lot of code that goes into organizing your test. Okay, you register it, you unregister it, you have that, and then none of it is actually needed here. You just write your test, and then actually this code is actually auto-generated by the tool, or it's managed by the framework itself. This is the result for another feature. So, original 10, but we have a lot of robustness failures. These are actually very simple errors. I mean, these are the APIs that don't handle null values, don't handle strings properly, or these are fairly common things, but still they need to be tested. Right? And then error handling code is, and then we have a sequencing bugs resulting from using the model 4. So, these are fairly significant development, improvement in terms of bug finding ability and bugs, it's fine. And changing the code is, there's a coverage built up about 10%, and again, the actual test code dropped in half. So, in conclusion, the comments are, well-designed unit test framework can boost the value of unit tests significantly. The new is actually used by hundreds of engineers. These are the people who write the code for these routers and switches, Cisco, and provides an excellent return on investment. MBT and became a mainstream techniques. Actually, there used to be a lot of question, reluctance. I mean, people felt that whatever complaints I had, I'm writing so much code and still I'm doing very basic testing, what's all that. So now we are telling that, don't worry about these things. We can do that, and we also provide a lot of tool support, the framework support, so that we actually see a lot of value in the test that you are doing. And I didn't give an example, but there's a built-in capability for performance and scalability analysis. Actually, as part of a test, you can decide that this is my scalability parameter. It could be number of sessions, it could be number of neighbors, it could be whatever it is that, if it's a data structure, number of elements, so on. This automatically lets you decide a vector of values for the parameter, scalability parameter. It would actually execute for all of them, and then will give you a pretty detailed information about which of the functions or which parts of the code is not really scalable. So that data actually can be exported into an Excel spreadsheet, and it actually plots. And if you have a ready a piece of information from which you can look at the performance of scalability issues. And then performance is actually pretty easy, because now in a way we are breaking up our test task into all these nodes and edges. The framework actually provides you the time spent on different nodes and edges. That itself is pretty valuable. It tells you, where the performance issues are. And then, like in a big company, you want to introduce something new, or adoption becomes an issue, so you have to put in extra work. But this was actually a company-wide effort. There was educational material, case studies, and a lot of people who were very enthusiastic to come and talk about their experience, and that's how it was actually made. That's how the concept spread across the engineering community. And then we also see that UT, as I quoted earlier, we used to have a serious problem. A good percentage of what considered the unit testing escaped, but actually they are reduced. I think that's so that's enough my presentation. But I'll be happy to answer questions.
Speaker.
Yeah.
Question. Thanks for the great talk. Actually, it's very interesting to see that you're doing so much work on the preventing the escape from the unit test. And as a tester myself, I really appreciate the kind of. So my question is, I saw that you're trying to construct a graph of test cases, and you're trying to execute the test cases in different kind of paths.
Yeah.
Is this trying to repeat something like functionality test, trying to
right,
troubleshoot some kind of end-to-end scenario instead of focus on unit tests on certain functions?
Yeah, right. See, there is a thin line of division. So even the units, they have their own set of APIs. So the APIs have certain use sequences, right? Typically, these are the APIs. So the scope here is within the unit, within the component. So basically, the graph is used for sequencing API calls. Okay. But same concept, actually, the same tool is also used by people that do black box testing, that do end-to-end testing, because the concepts are not that much different, right? I mean, you can, instead of writing API calls, you can actually, we had a tool that automatically generates test script based on the graph description. Okay. Yeah. So the concept is useful in unit testing also elsewhere, but here this is integrated with the framework, so it actually does the work.
So the graph you're talking about is more like built from the call graph, or it's like...
No, it's something entirely created by the engineer.
Okay.
Yeah, it's created by, it's not automatically generated. So the creative part is actually creating the other graph directly. Yeah, that's done.
Thanks.
Thanks. Yeah, go.
So this is my question is continuation of this question. What notation do you use for making the graph?
What kind of
notations do you use for making those graphs?
Oh, notation?
Yes.
Oh, yeah, let's go back to that. Okay. It's a textual notation. So here you are specifying a start node, and then you are specifying this is a node, and does the code associated with the node. And similarly, this indicates this is an edge from this to this node. Okay. This is a textual notation for describing the graph. And actually, somebody wrote a graphical tool, but you don't need to do that. Actually, what it does is it takes your input but generates this kind of description. Yeah, please.
Yeah, so if you're creating these graphs automatically, I understand how you can find faults and hangs and that kind of stuff. But how do you verify semantic correctness? What are you using for your workflow?
Semantic correctness is similar to what we do. I mean, there are asserts, obviously, throughout the code, assert violation, and there are also, people actually write different validators. Like, there are data structure, there's a routing table, there's a validator for that, there's a file system. So there are, actually, these are like the library of validating functions that are called there.
And those show up in this specification somewhere or elsewhere?
They do show up in that, so when you are talking about, when you are linking up, you actually link up those appropriate validator libraries. These are considered a shared resource in this thing.
Thanks.
Yeah.
Any other questions? Let's thanks to the speaker.